Hi, and welcome to this video series. In these videos, I will show you a very simple neural network project that estimates a single parameter function like the sine of x or floor of x. This project is a perfect example to start learning the concept of training a neural network without the complications of more complex tasks. But even though the goal is simple, you will see that many of the considerations that you will have to consider in more interesting projects will manifest themselves here as well. In this series, I will use PyTorch, which is a deep learning framework developed by Facebook. In the first video, I will go over the code that we will use during the series. I will try to explain the overall things you need to know, but not going down into the rabbit hole of every single details. This series is meant for people who have little or no experience with deep learning projects, but have some ideas about the concepts of deep learning. If you don't get the details of it, don't worry and don't let it intimidate you. I was in the same spot when I started my first project. But after you have accomplished a few tasks with neural networks, all the statements and tricks that you know about deep learning will become much clearer to you. Just bear with it a little. Also, the code that you will see will repeat itself with minor changes over your projects. After we are done with the code, I will go over the considerations you need to take into account. First, why do we need a GPU for training and why it performs better than a CPU? Then I will go over the first thing that you should specify in a neural network projects, and that is the architecture of your network. And by architecture, I mean how the layers of your model are organized, how many neurons are in each layer, and how to assess which model works better. In this series, I will only use feed-forward layers or the linear layers in PyTorch library. I will cover other types of layers, such as convolutional or CNN convolution transpose or recurrent neural networks like the GRUs and the LSTMs. In other series. So stay tuned and subscribe to the channel if you want to see them as well. After that, I will show you a key point in making neural network perform correctly that is oftentimes overlooked, and that is the normalization of the input and output of a neural network. And I will show that with a few examples. After that, I will go over the epoch count effect on training a model. Unfortunately, the example is too simple to fully cover this concept, but I hope that it will give you a general idea on how to interpret and how to choose the epoch count. The next video will cover the learning rate, which is a crucial hyperparameter to tune. I will show that what will happen if the learning rate is too small or too large, and how to find a learning rate that works best with your project. After that, I will show how two optimizers lead to very different results. Even though you will usually go with the Adam optimizer, it is always good to know how different choices impact your work. One of the important concepts that I learned in machine learning is the no free lunch theorem. Basically, what this theorem says in plain English is that there is no machine learning model that will always perform better than the others. And by different model, I mean different categories of machine learning models, like the probabilistic models, the tree-based models, the rule-based, or even the neural networks. In my experience, the same applies to other parameters as well. So it is important to know the assumptions that lead to a tool like the Adam optimizer or the stochastic gradient descent optimizer, the stochastic gradient optimizer. The next video will show examples of activation functions and how they affect the model. There is a hype that the ReLU is the best activation function to go, but this is not always the case. In fact, the example that you'll see will work better with the 10H activation function, even though it is a much more dated function. Next, I will show you how the batch size affects the training process. And finally, I will conclude this series. I'm excited to share this example and my experience with you. I hope it will help you understand better neural networks. And one more thing, this is my first series that I publish on YouTube, so please leave comments on things that you think will improve my work and leave a thumbs up on the videos. It seems that it matters in YouTube promoting my videos. So without any further ado, let's jump into the code of the video series.